we give you many different type of definitions there. And now when you talk about physical properties there, we use two other terms to describe the physical property. One is what we call extensive property. Now extensive property by definition, it depends on the amount of matter. Can you think of an example?
Mass and volume.
Mass and volume. Okay. 500 milliliter of water versus 1,000 milliliter water. The volume changes. Volume is a physical property. And volume change and volume depends on the amount of water you have there. Mass also depends on the amount of water there. Now there are certain things that does not depend on the amount of substance that we're studying there. And that's what we call the intensive property. Intensive property does not depend on the amount of substance present. One example would be density. Now density by definition, we will introduce this definition in just a little bit. Density by definition is the mass, that is the ratio between mass and volume. So if you have a bigger piece of matter, you would have a greater mass, also a greater volume there, and the ratio stays the same. So the density of water, we say the density of water equals to 1 gram per cubic centimeter. Whether you have a bucket of water or a whole large, very large container of water, the density of water does not depend on the quantity here. So that's the key here. One depends on extensive property, depends on the quantity. Intensive property does not depend on the quantity here. And melting point is another example of intensive property. Ice will melt when the temperature goes above 0 degrees Celsius, or at 0 degrees Celsius, ice and water will actually coexist at 0 degrees Celsius. But if you raise the temperature above 0 degrees Celsius, ice will melt. It doesn't matter how much ice you have there, and that's the melting temperature there. Okay, so it doesn't depend on the amount of ice that you have there, although it may take longer for a larger quantity of ice to melt. But as long as you have the temperature above the melting temperature, above the melting point of ice, and the ice will melt. It may take longer for a larger quantity there, but the melting temperature itself does not depend on the quantity. So these are the two new terms that we use to describe physical property there. And here's another exercise problem there. Say we have a piece of gemstone, if you will, work with there, a blue-green solid. It has a density of 2.65 gram per cubic centimeter, a mass of 2.5 gram. So which quantity is extensive? Which one is intensive? Well, density is intensive. Mass depends on how big this piece of stone is. So mass is extensive there. So the next question here, what is the volume of this piece of gemstone? Well, in order to figure out the volume here, well, we have the density here. The density, if you look at, this is what we call the unit of this quantity there. This is the volume, this is the mass. Here, that's the mass in grams. So density by definition this is probably the first definition that we actually use a mathematical equation to relate all three quantities together. Density is the ratio between mass and volume. If you know, out of these three terms there, if you know two of them, you can figure out the third one. So in this case, we have 2.65 gram per cubic centimeter equals to 2.5 gram divided by x. X is the volume. The question is asking you to determine the volume there. All you need to do is to move the x to the other side of the equation, put 2.65 underneath here. So gram and gram will cancel out. The volume will have a unit of centimeter cube, or cc, that's milliliter, equivalent to milliliter. Now, what we have discussed here is that you have, for any measured quantity in chemistry and physics and science, you have to make sure that you not only include the magnitude of that measurement, you also have to have a unit in there. When you say we have a certain amount of water, 2 gallons of water, 3 gallons, that gallon is the unit there. Okay, and a number in science, in chemistry and physics, a number without a unit is meaningless. Okay, so that's something that you have to keep in mind there. You always pay attention to the unit. And the next topic that we will be talking about in this chapter would be what we call dimensional analysis. Dimensional analysis is all about the units there. You are converting one subunit into another subunit. So 12 inches, we want you to convert it into centimeters. You have to pay attention to the units in there. Okay, so that's something that's very important, and you need to make sure that this is the first equation that we introduced in this course there. Density equals to mass over volume. Okay, you need to know this definition, and we will ask you to calculate density sometimes. So you have to, in order to calculate density, you have to be able to figure out the mass, you have to figure out the volume there. Sometimes mass and volume are not directly given. With the information present in a particular question there, you may be able to figure them out. And then once you know the mass, once you know the volume there, you can figure out the density. Or sometimes we give you the density, like this one, like this particular question there, we give you the mass. Now we ask you to figure out the volume there. So this is the calculation part of this course. You need to be able to do calculation. Okay, so we want to move on to the next, since we are talking about the units there, we want to move on to the next learning objective here. And here we want you to be able to recognize and use metric prefix and metric prefix multiplier. And also we want to introduce what we call the International System of Standards, the SI units there. So for any quantity that we measure here, it has to carry a unit. A number without a unit is meaningless. Okay. Also, we want you to be able to manipulate numbers, converting a decimal number into scientific notation, or the other way around, giving you scientific notation, you need to be able to convert it back into decimal numbers there. So that's what we're going to be looking at in the third learning objective here. So SI unit, International Standard Unit for measuring quantities there. Length is measured in meters. Unfortunately, it's not in foot or in yards, it's meters. Okay, the symbol that we use for length is meter. A mass is measured in kilogram, not in pound, not in ounces, but in kilogram. These are the standard units there. Okay, time, second, and temperature, Kelvin. Not Celsius, not Fahrenheit, but Kelvin. Okay, and then the amount of substance that we measure, talking about the chemicals there, we use the unit, we use mole as our unit. And the symbol would be MOL. Electrical current, amps, and luminous intensity, candela. These are the 7 basic units that we use to measure pretty much all of the quantities that we have there. And there is, of course, different types of measurement. As we all know, when you measure the length there, you can measure it in the British system in foot and inches there, and we can also measure them in meters and centimeters there. Now, in a metric system there is a conversion factor that you need to memorize. Okay. Now, some of these prefix and multipliers we use them on a daily basis. Especially these days, and in the digital world, you always hear the term gigabytes. And what is giga? And giga is 10 to the 9th, 1 billion. Okay. And in addition to that, we have hexapeta, tetra, tera, giga, mega, kilos, and so forth. These are the things that we do want you to pay attention to. Now, we use these prefix multipliers to convert one particular unit to the other. Now, I don't need you to memorize all of these things.